Okay, good afternoon all. Today, myself, Professor Devendra Parmar, Assistant Professor, Department of Mechanical Engineering, PhD College of Engineering and Technology. Today, I am going to present one small introductory video by three-dimensional printing, which we are called as a 3D printing. We are a future of a manufacturing technology. So let us have a look to this new era of the manufacturing. So actually, first question comes that what is 3D printing? We are knowing about the paper printing and all these things, but what is 3D printing? So here is the definition of that. 3D printing refers to a relatively new class of manufacturing which quickly produce physical prototypes from a 3D CAD data. So this is, I am having a CAD model, it's a three-dimensional model, and then this is my final part which I am using to reproduce the things or as a prototype. So it's a 3D printed part, layer by layer manufacturing process. Okay, it is also known as a rapid prototype, layer by layer manufacturing and additive manufacturing. So how actually 3D printing works? So this is my CAD model. I will slice into a multiple layers like 1 layer, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, multiple layers as per the resolution. Then after that I will pasting a layer one by one in a particular sequence. So it will generate a physical prototype. So this is a basic phenomena of the 3D printing process. That is a layer by layer addition. So that's why it's a additive manufacturing. So here this is a 3D printing machine, or we say 3D printers. So let us have a quick look to one FDM technology of a 3D printing. It's a one brand Tico which produces the 3D printing. Yeah. So let us have a quick look about what is the FDM 3D printing modeling. This is a basic view of that. So fused deposition modeling, the full form of the FDM is the fused deposition modeling. Fused deposition modeling is a layer additive manufacturing, or say we can say a 3D printing process that uses production grade thermoplastic material to produce both prototype and the end use parts. A very simple way to describe FDM is to think of it like a hot glue gun. So think that we are having a hot glue gun. With the use of that we can build a layer by layer particular one part. So according to this, that hot glue gun is mounted on some motors that can accurately place the molten glue on an X, Y and Z axis. Once the glue has been put wherever it's needed to be, the built platform will move down one layer. So again this same procedure will be repeated. So one layer, second layer, third layer. So continuously repeating of this particular process, it will print a complete 3D part. So obviously it can be used for a little small parts, or it can be used for a complex geometry also. FDM was invented by Scott Crump in late 80s. After patenting this technology, he started the company Startist, now one of the largest manufacturing company of the 3D printer in the world. So the word particular FDM, that is a fused deposition modeling, it is also a trademark of the Startist company. Although the term FDM is widely used and describe this technology very well. So let us we have a particular this 3D FDM. How actually FDM works? Okay, so this is my build platform, this is my form base, this is a support materials, part support, and this is the actual part. So the dark blue is the part and the light blue is the support material. This is the two spools. This is a build material spool. The dark blue one is the build material spool and the light blue one is the support material spool. So it can be fed into this particular extruder. This extruder head consists of these particular things. It consists of extrusion nozzles, this is, and the liquefier and the drive wheels, and one is the support material. One nozzle is for the support material, second nozzle is for the support material. So whenever it fades into this platform goes down, again this will print a particular one layer on this, again platform goes down, again one layer of this, again platform goes down. So this process is continuously repeated. So due to this process we can easily build a particular part with the use of part material and also with the use of support material. So built material spool we needed, and one spool is needed, that is a support material. Okay, so this is the basics working process of the FDM technology. So now after having a basic look on FDM technology, we will move towards one particular video which will easily describe the 3D printing FDM technology. Okay, so this is a particular video for that. So this is how actually a 3D printing FDM technology workstation works. This is the printing of a particular metal parts. So now layer by layer manufacturing is going on. You can see that. So actually, what is the basic idea about the FDM? That is the fused deposition modeling layer by layer. One layer, second layer, third layer, one part, second part, third part. So it can be used a particular one 3D CAD model first of all. Then there are two spools as we discussed for before. The first spool is for the support and second is model material means okay. So this is a particular way of spool, one support and one, this is a particular path which is fed through the extruder nozzle. So this is a particular path where the wire is fed into the extruder nozzle. So this is a blade first platform. So here we will push the video and see, this is a built up material, this is a support material, this is actually a drive wheels which we have seen in that particular figure. This is a liquefier. Actually the main material is not in a molten state, it is a semi molten state, and this is the extrusion nozzle. So it will fed the support material one layer, this is the second layer, this is the support and build material, support material, again a build material. So one by one layer is supporting, support, again a build, support, again a build. So layer by layer we can easily, white is the support material and black is the built material. So layer by layer we can manufacture it. This is 1 2 3 4 5 up to many resolutions we can go with the layers. So after the completion of the particular printed we can remove the particular part like this, and but yeah, you can see that this is not a precise part on a surface finish. After having a brief idea about the FDM technology, welcome back to the our main presentation. So actually 3D printing doesn't require any particular mold. So here we are seeing that this is a bit complex system. So for manufacturing it with the conventional system like a casting, we require a particular mold. So that mold for that particular mold we require a particular pattern. So first step is the pattern, second one is the mold, third thing is the casting and pour. Okay, so if we can use a 3D printing to manufacturing this particular product, so it doesn't require any particular mold. So if there is a no mold, so there is a no pattern. So it will directly cut down these two cost of pattern and mold. Again, let's take this example. If I want to make a one TV remote with the use of conventional process, say casting. So for that, or say forging or say casting. Okay, for the casting, we require this much amount of mold. So directly we can mold it. But if I will made it with the use of 3D casting, it doesn't require this. So it's a purely a great advantages and a cost saving. Okay, this is the best example which I can share with you all. So multiple parts can be produced in a one particular cycle. If I am designing a one cycle, part 1, part 2, part 3, part 4, part 5, these all parts can be produced with the use of 3D printing in a one particular cycle. This is one more advantages. Like the small parts, it's micro level parts to the big parts, both can be printed successfully with the use of 3D printing. So the 3D printer has been used successfully to make a parts of different size, micro to macro. So complex geometric complexity is not a limitation in 3D printing. It's always play a vital role when it comes to a geometric complexity in a traditional manufacturing. So there are a lot of technique. One is FDM, second is 3D inkjet printing, third one is laser engineered net shaping, fourth one is the selective laser centering, fifth one is electron beam melting, and lot more. So there are many rapid prototype techniques which we are using right now in a recent age. This is a MakerBot, the one of the leading manufacturer of the 3D printing. So touch and feel, we can have a sand printers which can give a touch and feel type of environment, form, fit and function. You can easily understand from this particular 1, 2 and 3 figures. The application of wind tunnel testing, if I want to test my particular model, so I can do the wind tunnel testing. Application of 3D printing, validation of your invention. Yeah, you can easily judge from this particular figure. So patterns for the casting, molds for the casting, sand mold, particularly with the use of sand 3D printers. Then in jewelry, the complexity, see the complexity of the particular ring. It easily can be 3D printed with the use of 3D printing technology. So different type of complex shapes. Yeah. We can see the figure. Yeah. Then application reverse engineering. I can scan this particular model having some changes in per particular model and I can 3D print it. So it's a replication of that particular model. So it's a reverse engineering. We can use it also in a reverse engineering. Yeah, 3D printing can be makes up parts in a biocompatible materials. So we can use it in a medical implantations. So if this skull has a hole over here, I can with the 3D scanner, with the advanced CAD tools, I can produce this kind of bio material. I can put it on my skulls. Yeah, so easily work with the medical implants. Different applications, prototype for the medical implants before surgery, after surgery, whatever the applications are there. Okay, mass customization. If I have different teeth, I can produce it with the use of only one cycle. Different shape I can print in a one particular cycle. So these are the materials: metallic materials, polymers, and polyceramic material, other materials, and biocompatible materials. There are some limitation of the cost, accuracy, finish, strength, and the material options. So that can be a one more major criteria for the 3D printing. So that's all about my presentation, and we will see a basic process how to make a 3D model, how to generate the STL file, and from that STL file how to go with the pre-processing of the 3D printing.